Alright, so in this video I'm going to talk about section 6.3 from the book. The name of the section is Separation of Variables and Logistic Equation. So in this section we will learn techniques of solving a differential equation. The name of the technique is called separation of variable. Okay, so this type of method is used only to solve certain type of differential equation that can be written as a separable form. So you will know what is separable form. But so there are several techniques to solve a differential equation. Separation of variable is one technique. Solving a linear equation is another technique. Exact equation is a. So there are so many other techniques which you will see in the differential equation class. But this is just the beginning, the first method of solving the differential equation, and you will see this method again in differential equation class. Okay. So what type of equation is called separable? Is if suppose you have a differential equation given like that, okay, dy over dx equals to f of xy. There may be function on the right hand side, this function of x and y. If you can write the right hand side as the product of two functions, separate function, one is function of x times another is function of y. You can separate, if you can separate the right hand side as the product of two functions, one is function of x and another is function of y, then we call that type of differential equation is separable. Separable differential equation. If the dy over dx is on the left hand side and in the right hand side there may be any function, but if you can write that function as the product of two functions, one is function of x and the other is function of y, then that type of differential equation is called separable differential equation. Now how do we solve that type of differential equation? Is what we do is you separate x and dx in one side and y and dy in other side. That means you have dy over dx equals to fx times fy, f1x times f2y. Now what I'm going to do is I'm going to divide both sides by f2y. Then you will get 1 over f2y and dy, and then that dx goes to the other side in the differential form, and then f1x and dx comes on this side and 1 over f2y dy is on the other side. So you see that on the left side there is just function of y and the differential dy, and on the right side there is function of x and the differential dx. So this is separable, so we are able to separate that. After you separate, then you integrate on both sides and solve for y if you can solve for y. If you cannot solve for y, just write down whatever equation you get. Okay, so let us see some example and then you will understand this method better. But first of all, not all differential equations are separable. Some of the differential equations are complicated or so integrate that that you cannot separate x and y functions and then write in the product form. You cannot do that. So only some of the differential equations are separable, and if the differential equation is separable, it is easy to solve. Okay, so let us do very first example. We have dy over dx equals to x times y over x squared plus 4. So is it separable? Is it, can you write this as x times function of x times function of y? Yes, because this is x over x squared plus 4 times y, right? So this is like f1, this is like f2, right? So how do I solve this? So this is a separable differential equation. Now how do I solve this? Move that y on the other side. How do I do that? You can write 1 over y dy equals to x over x squared plus 4 and then dx. You see that these are separated. Now after you separate like that, then you integrate on both sides, right? How do you integrate that? Integrate. So on the left hand side, what do you get? On the left hand side you will get natural log of y is equals to, on the right hand side you see that what is the function in the denominator? X squared plus 4. What is the, how do I do this type of integral? Because there is x in the denominator, the derivative of x squared plus 4 is 2x, but there is just x. So what I'm going to do is I want to do 1/2 times 2, so that the derivative of the denominator function is in the numerator exactly, so that the integral of that is natural log of the denominator function. You know that, right? In chapter 5 we learned that type of integration. So what do you get? You get 1/2 and natural log of the denominator function x squared plus 4 and then plus c. You write c, but let us write down log or ln c, so that all of them are so let us write down ln c. Why did I do that? So that I can just combine them, because this is just a constant. You can write just c or natural log of c, not a problem. Okay, if you write natural log of c, then you will see in the better format, but it doesn't change the answer. Okay, so what do you get here? Then I want to combine the log in the right hand side. There is natural log of y in the left side, and you can write natural log of x squared plus 4 to the 1/2 plus natural log of c. Now I want to combine the log in the right side. You can write natural log of y on the left, natural log of c times root under x squared plus 4 on the right. You see that? I combine those. Now natural log cancel out. You can think. So therefore y equals to what? C times root under x squared plus 4 is the final answer or the solution of this equation. You see that? So if the differential equation can be written as the product of function of x and function of y separately, that is called the separable differential equation. And to solve the separable differential equation, what we do is we write all the y function and the dy in one side, and then function of x and dx in the other side, and then we integrate. Okay, let us see another example. Here you have y ln x equals to minus x equals to so minus x times y prime equals to 0, right? So what I want to do here is I want to write like this: y ln x equals to x times dy over dx. You see that? So you can write like this. So I want to separate. Okay, how do I separate that? I want to divide by x and divide by y. So what do I get? I'll get ln x over x equals to 1 over y dy and then dx. So I wrote that dx on this side. Okay, so ln x over x dx, okay, equals to 1 over y dy. So they are separated. Okay, now what do we do? I want to integrate on both sides. So what is the integration of this? So you can write ln x equals to u. You can do u substitution. What do you get? 1 over x dx will be du. So u du, right? So that is what is the integral of u? That will be u squared over 2, right? And then if you do that, so you can separately do what is the integral of ln x over x in separate. Okay, so how do I do that? Is you can write ln x over x integral dx, right? Say ln x equals to u, then 1 over x dx will be du, right? So you get integral u du. What is the integral of that? U squared over 2, right? So that is natural log of x squared divided by 2. That's what you get. Okay, so what I'm going to do here on the left side is natural log of x squared over 2. You see that? That's what you get on the left hand side. Now on the right hand side, it is natural log of u. You see that? So on the right hand side, that will be natural log of u. Let me erase that. Sorry, natural log of y. So on the left side, we got natural log of x squared over 2 equals to, on the right side you get natural log of y, and then we usually write plus c at the end if there is any. Now we cannot combine that. I mean, you can keep like this, no problem at all, or if you want to, you can bring that to the left. You can write natural log of y equals to natural log of x squared over 2 minus c or plus c, not a problem. So you can write that way. So this is the answer, but if you want to solve it for y, you can do that, but this is okay to write. Okay guys, so how do I do this problem here? This is the initial condition is y at y prime. Hold on, this is at y prime. So this is at root x plus root y times y prime equals to 0 and y1 equals to 9. This is question number 20 from the book. So and y at 1 equals to 9. This is initial condition is given, you want to find out. So whenever initial condition is given, you will be finding the particular solution, because that value of c will be replaced by whatever value of c we will get using that condition. Okay, that will be the particular solution. So let us do this problem. So again, this is separable. Why? Because you can write this as root x. So let me write this way so that it will be easy to see. So root y and then dy over dx equals to negative root x, right? So how do you write that? You can write root y dy equals to negative root x dx, right? This is what you get. Now if you integrate, what do you get? If you integrate on both sides, so let us integrate on both sides. You get, so root y is y to the 1/2. So y to the 1/2 plus 1 is, you get y to the 3/2 over 3/2 equals to minus you get x to the 3/2 over 3/2 plus c. You see that whenever you integrate, you write plus c. Although you get plus c on the left side and plus c on the right side, you combine those two constants and get a bigger constant c. Okay, so what do you get? You get 2/3, okay, and then y to the 3/2, all right, and then you can write equals to negative 2/3 y to the 3/2 plus, you can write 2/3 c and then cancel that 2/3 and 2/3 and 2/3, because if you write, instead of writing c, you can write 2/3 c. This is just a constant, you can write any format, right? And if you write 2/3 c here, you can multiply by 3/2 and then that will cancel out, right? Oh, by the way, that is x, okay, that is x. So what do you get? Y to the 3/2 equals to negative x to the 3/2 plus c. You can write that way. Okay, now what is the c value though? So you use y of 1 equals to 9. When x is 1, y is 9. So you get 9 to the 3/2 equals to negative 1 plus c, right? What is 9 to the 3/2? 9 is 3 square, right? 3 square to the 3/2. You see that? So 2 and 2 will cancel out. That 2 and 2 will cancel. 3 to the, so equals to minus 1 plus c. What do you get? C is, this is 27, because 3 to the 3 is 27. And then plus 1 will be 28. So c is 28. You get c is 28. Okay. Now you plug in here. So you get, therefore the final answer is y to the 3/2 equals negative x to the 3/2 plus 28. That's what you write. So that is the answer. Okay, negative x to the 3/2 plus 28. But if you want to, you can write like y to the 3/2 plus x to the 3/2 equals 28. That's the answer of this differential equation. So again, if the differential equation is separable, or if you can write the right hand side function dy over dx equals to right hand side function as the product of two functions, function of x and function of y, then it is easy to solve that equation. Let us do this example. Xy dx plus e to the negative x squared and then y squared minus 1. Okay, xy dx plus e to the negative x squared y squared minus 1 dy is equals to 0, and it is given that y0 is equals to 1. So you want to find out the particular solution. You see that this is a particular solution. It does not have any c in it, because you find out the c equals 28 and you plugged in there. Okay, so you got that. Now what you want to do here is, so let us do this problem. So we want to, first of all, we want to write in the separable form. So how do I do that? So let us write down this as, so this as e to the negative x squared. Okay, so let me write down, we have xy dx plus e to the negative x squared and then times y squared minus 1 dy equals to 0, right? See that dy must have just y term and dx must have just x term. How do I do that? Let me divide by y. What do you get? X dx plus e to the negative x squared y squared minus 1 over y dy equals to 0, and I want to divide by e to the negative x squared. What do you get? So x over e to the negative x squared, right? E to the negative x squared. Here I was dividing by y on both terms. Then you cancel that, and then what is left is that. Now I want to divide by e to the negative x squared. Okay, that will cancel out. So what is left here is, if you move this to the top, you will get this. You get x e to the positive x squared, right, dx. See, all the terms have x only, plus you do y minus 1 over y dy equals to 0. So it is separable form. You see that this is separable form. Now we need to integrate on both sides. If you integrate this, what do you get? You can put x term in one side and y terms in the other side of the equal to sign and then integrate, or you can integrate in one side altogether. That is perfectly fine. Okay, so if you integrate this, what do you get? You see, you do that x squared equals to u, right? You need to use substitution. Then 1/2 du. So you will get 1/2. The derivative will be, let me show you that thing here, right here, because I have little space here. I want to show you that thing. Okay, we do x squared equals to u, then 2x dx will be du. So x dx will be 1/2 du, right? So you will get x dx will be 1/2 du, and then you get e to the u. So what is the integral of e to the u? E to the u itself. So you will get basically 1/2, and then so you will get on this side, you will get basically 1/2 and then e to the x square, right? That's what you get. Let me write down that 1/2 e to the x square. That's the integral of the first term, plus the integral of that is y square minus natural log of y, right? And then plus c equals to 0. That's what you get, right? Now we need to find out c though. So we need to use the initial condition. The initial condition is y at 0 is 1, meaning when x is 0, y is 1. Okay, so at x equals to 0, y equals to 1. That's what we are using. Let us use that. What do you get? 1/2, that will be 0, plus 1 minus 0, because natural log of 1 is 0, plus c equals to 0. What do you get? C will be -3/2. That's what I get, right? Basically c is so 1/2 plus 1, right? And then oh, by the way, what is the integral of y? It is y squared over 2. I forgot that. I'm sorry about that. So it will be 1/2 again, right? So 1/2 plus 1/2 is 1. So c is -1. That's what we got. Now plug into that equation. What do you get? You get 1/2 e to the x squared plus y squared over 2 minus natural log of y plus c is -1. Let's write down -1 equals to 0. If you multiply both sides by 2, what do you get? You get e to the x squared plus y squared minus 2 natural log of y minus 2 equals to 0, right? You can write that way, but if you want to, you can move that 2 as in the exponent of y and making natural log of y square. You can do like that, or you can keep like this. Okay, so this is how we solve a differential equation that is separable. Okay guys, so the next thing I want to do is the logistic equation, which will be in the next video. All right, thank you guys.